So today, 7E.3, and maybe a little bit of a challenge, so we'll just try and go through it nice and slowly, make sure you show you how we're solving this. But what we're doing, we're solving trig equations, we're using algebra. So for the algebra and the unit circle, so we're going to need our unit circles as well. So the first one here, we're trying to find x, given that sine x equals 0.5. So this is as simple as looking at our unit circle and saying, what are the solutions between, for one revolution, between 0 and 2 pi? So if this is our unit circle, right, remember sine is the y values, so we're trying to find when the y value is half. So we're looking at that point there and that point there. Those are the two angles that we're going to have. So from our unit circle, if you have a look at your unit circle, those will be pi on 6 and 5 pi on 6. They're going to be our two answers for this one. Not too much involved there. Okay, if we have 2 cos x take 1 equals 0, what we need to do is we need to isolate cos x by itself. So we're going to start by rearranging this. We'll have 2 cos x is 1, and we'll have cos x is half. All right. So again, let's picture it on the unit circle. Cos is the x values. All right. So this is where x is positive 1. So x being positive half is here. So the coordinates on the unit circle are going to be this one and this one. Okay, so let's have a look at your unit circle and see if you can figure out what are the values of x that are going to make that true. That the x value is half. Our angle is going to be pi on 3 to be 1. And 5 pi on 3. Okay, but we haven't finished, all right, because when we're doing these questions, we need to take into account the boundary. All right, so in the first question it said between 0 and 2 pi. That means 1 revolution of the unit circle. Here we have between 0 and 3 pi. So that's going to be 1 revolution plus another half of a revolution. Alright, so within the first revolution, we generated these two answers. But then when we're going around the second half, we get this solution again. We get that solution again. It's in the same coordinate, but, so pi on 3 is the value of that one, but it's 2 pi units further around. It's a whole revolution further around. So we'll perform this just using fraction operations. It's going to be pi on 3 plus 6 pi on 3. All right, 6 pi on 3 is 2 pi, which makes it 7 pi on 3. So our 3 solutions then, we need to summarize our 3 solutions that satisfy this equation. X is pi on 3, 5 pi on 3, and 7 pi on 3. They're the 3 solutions that occur between 0 and 3 pi. Let's parallel that with the graph of cos x. That's what we're graphing, isn't it? So if we graph cos x from 0 to 2 pi, this is what we'll get. And if we graph it to 3 pi, it'll end up down here. Okay? And we're saying, what are the solutions that make the y value, or the x value? Okay, this is the x value on the unit circle along here, and this along here is the angle. This is the x value. What that make the x value equal to half? And so we've got, here's one, here's another, and here's the other. All right, and they are pi on 3, 5 pi on 3, and 7 pi on 3. Okay, so that's the connection between the graph. Okay, let's move on to C. We've got 7 tan squared x equals 21. So we're going to need to isolate tan x by itself. So firstly, we'll have tan squared x is 21 on 7, which is 3. And then we're going to square root both sides to get tan by itself. We'll have tan x is plus or minus root 3. Okay. So tan we know is sine on cos. Alright? And if we look at our unit circle diagram, we don't have the tan values listed on there. We've only got the y value and the x value. Now you could go the whole way around your unit circle and try and find where is tan root 3. Where is tan going to equal? Plus or minus root 3. All right? So you can put all the tan values on there. It's going to follow this pattern. So I might just do the first quadrant here. When it's 0, it's undefined. Here it is going to be 1 on root 3. Here it's going to be 1, and then here it is going to be root 3. And then here it is going to be 0. Okay, so it's going to follow that pattern as it's going around. It's going to replicate itself. So you can figure that out just by doing the y values divided by the x values. Now, how did I know that, right? Let me explain a bit about us making connections with the unit circle. I'll try not to spend too long here because you're going to have one. But when I'm trying to solve a problem like this, right? If we just imagine this quadrant, okay, the first coordinate is pi on 6. That's the first angle, pi on 6. Now, at that angle, clearly the x value is bigger than the y value. Right? The x value is bigger than the y value, which means the x value is root 3 on 2 and the y value is half. Okay? The next point is 45 degrees, and that's where they're equal. They're both root 2 on 2. And the next point is pi on 3. Pi on 3, 60 degrees. And clearly at this point, the y value is larger than the x value. All right? And so at this point, the y value is root 3 on 2 and the x value is half. Okay, so that's how I'm picturing the unit circle in my head. I'm just going, which one's bigger? And I'm knowing it either takes one of these 3 values. All right? Apart from these points, which we know are 1, 0, and 0, 1. And then I'm saying, now tan is sine divided by cos. And so that means we need to have, if we do root 3 on 2 on 1 on 2. Okay, root 3 on 2 on. So sine on top of cos, we're going to have root 3 at the top, 2 root 3 at the top, and 2 times 1 at the bottom. The 2 can cancel and we're left with root 3. So that means tan is going to be root 3 whenever sine is root 3 on 2. All right? That's how I'm thinking about it. Okay, so that means our solution is going to be pi on 3, 2 pi on 3, pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. Okay? So if you're not sure about my thinking there, you can spend some time, go the whole way around the unit circle, and put all the tan values just by doing sine on cos. All right? Okay, sine 2x is root 3 on 2. So this one looks reasonably easy because we have the values given to us straight away. You don't have to do any rearranging. The difference is, however, see this 2x in here? Whatever that number is, we need to multiply the region by that. Okay? So because we have sine 2x for root 3 on 2, that means we need to restate the region. Is 0 is less than 2x is less than 4 pi. I'm multiplying every value along there by 2 because there's a 2 in front of the x. Alright, so we've got 0, because 0 is less than x less than 2 pi, therefore 0 is less than 2x, which is less than 4 pi. Now where is sine root 3 on 2? So again, we can think about these things. Root 3 on 2, it's about 0.806, or 866. So if here's 1, 0.866 is about here. So it's going to be that point on the unit circle and that point on the unit circle. Remember, sine is the y value. So we're going to need that angle and we're going to need that angle. Okay, and so what we'll have is we'll have 2x is going to equal pi on 3 and 2 pi on 3. Alright, that's when it's going to be positive root 3 on 2. Within the first revolution, because we have our new domain here. We have to go out for 2 revolutions. So that means what we need to do is both of these solutions we need to add 2 pi to. So we've got pi on 3 plus 2 pi and 2 pi on 3 plus 2 pi. Okay, we've seen before we need to make them have the same denominator. That's pi on 3 plus 6 pi on 3 and 2 pi on 3 plus 6 pi on 3. So these simplify to be 7 pi on 3 and 8 pi on 3. So that means all of our solutions, we need to list all 4, are going to be, I'll write them here actually, so let's take that off. 2x is pi on 3 and 2 pi on 3. That's within our first revolution. And then we have 7 pi on 3 and 8 pi on 3. Okay? But we're not finished yet. We need to get x by itself. Here we've got 2x, we need to get x by itself. So we're going to divide both sides by 2, or you can think about it as multiplying both sides by half. So if I half this, I'm going to get x, and if I'm multiplying pi on 3 by half, I'll do it here, pi on 3 times a half, we've got pi on 6. Okay? So every one of these denominators is going to change from 3 to 6. Pi on 6, 2 pi on 6, 7 pi on 6, and 8 pi on 6. Okay, so we've listed all of the answers there, but we haven't listed them in simplest form. Okay, pi on 6, pi on 3, 2 pi on 6 is pi on 3, 7 pi on 6, and 4 pi on 3. Okay, so I'll just explain that process again. Because there's a 2 here, we need to multiply the region by 2. Okay, so that means we need to consider 2 revolutions. We find the solutions, all right, and then we say, well, that's within the first revolution. We need to consider the second revolution. That's what this was here. Okay, and then we say, now we list all the solutions. We have 2x is equal to all of those solutions. So therefore, x is equal to all of these, and then we simplify them. Okay, what does that mean in the context of this problem? So remember, sine x has a wavelength of 2 pi. Sine 2x means there are 2 wavelengths in 2 pi. So here's 2 pi, here's pi. What it means is we have one wavelength there, and then another wavelength there. We have 2 wavelengths in 2 pi. And so then we're saying sine is root 3 on 2, that's 0.86. That's these 4 solutions. Okay, that's what we found there. We found them exactly. Okay? Cool. Any questions so far? Okay. This is a pretty hard one. Get involved here. What's the region we've set between 0 and 4 pi? Okay, so the very first thing to do is go, what's the coefficient of x? It's 0.5. So that means we need to multiply our region by 0.5. So we're going to have 0 is less than half x, which is less than 2 pi. And then we're going, when is the cos value equal to 1? So on the unit circle, the cos value is the x coordinate. It's equal to 1 when the angle is 0, or when the angle is 2 pi. They're going to be our solutions. So we're going to have 0.5 times x take pi on 2 equals 0 or 2 pi. So then what we need to do is divide both sides by 0.5, okay? Or you can think about it like this, 0.5 is a half, isn't it? Okay? And so what we can do is multiply both sides by 2. So if I put 2 times here, and then 2 times over this side, we're going to get 0 and 4 pi as our solutions. But then we've got x take pi on 2 equals 0 and 4 pi. So to get x by itself, we need to add pi on 2 to this one and to this one. So we've got 0 plus pi on 2, which would be pi on 2. And we've got 4 pi plus pi on 2. Okay, this is pi on 2. And this one, we can calculate it here. I might just do it really quickly. It'll be 9 pi on 2, right? But it is beyond the domain we're interested in. We're asked between 0 and 4 pi, okay? 4.5 pi, or 9 pi 2, is beyond the domain we're interested in. So this is not a solution that is relevant to us. So there's only one solution that makes this statement true. Okay, well, let's think about this one graphically. So we have half a wavelength in 2 pi, which means we have a whole wavelength in 4 pi. Now we have shifted it pi on 2 units to the right. So normally cos starts here, but we're moving it to the right, which means it now starts here. And we're saying, when is it equal to 1? When is it equal to 1? So that's when it's going to equal 1, and that value there is going to be your pi on 2. Okay? Next one. Is that all?
There's one more.
There's one
One
more in
more?
the book.
The last one. I haven't written it up here. Tan squared x on 2 equals 1. So 0 is less than x, less than 2 pi. Okay, so we need to square root both sides to get tan x by itself. Now, just perhaps before we do that, we can write that like this, half x, isn't it? X on 2 means half of x. So that means we're going to need to halve this, isn't it? So we're talking about 0 less than half x less than pi, which means we're not even talking about a whole revolution, we're only talking about half of a revolution. Square root both sides, so we'll have tan of half x equals plus or minus 1. Alright, it's going to be plus or minus the square root of 1, which is plus or minus 1. And then, on the unit circle, we're looking for solutions when tan x is plus or minus 1. Well, tan is going to be plus or minus 1 when sine and cos are the same, because sine divided by cos is tan, and so when they have the same value, that's when it's going to be 1. That's at pi on 4, 3 pi on 4, 5 pi on 4, and 7 pi on 4. They are all the solutions where tan is equal to plus or minus 1. So we'll list them. We've got x on 2, or half x, I'll say it as. Half x is pi on 4, 3 pi on 4. Now I'm not going to list these solutions. How come?
It's outside
It's beyond
the
the domain.
range.
Correct.
The
It's outside the domain we're interested in. We're only talking from 0 to pi. We're only talking for half a revolution between 0 and pi. So then, to get x by itself, we're going to multiply both sides by 2. So it's going to be 2 pi on 4, or 6 pi on 4. And in simplest terms, pi on 2 and 3 pi on 2. They're the solutions that make this statement true. Alright, so a bit involved, pretty sort of big process. Let's see how we go with it, 7E.3.